Hello, this is my numerical calculation reassessment. I chose to do it on a horizontally launched projectile that is dealing with typical air resistance forces. The diameter of the ball is 0.08 meters. The ball has an initial velocity of 4 meters per second at a 60-degree angle between the XY plane. So we're only dealing with the velocity in XY coordinates. The initial position is the origin 000 meters. I wanted to determine the time the ball was in the air and the distance the ball lands from the initial X position while comparing this to the same values without air resistance. So for the program, I just made a floor as a horizontally launched axis, and then I made the ball a spear, an orange spear. I wanted it to trail the path that it is going to take. I put the gravitational vector in. I put the ball's mass. It is a 0.01 kilogram once you convert from grams. The velocity, I put the angle and converted it to radians. And then the force of gravity, I defined it as the ball's mass times the acceleration of gravity. And then I defined the initial momentum as the ball's mass times the velocity vector. And then for the air resistance forces, the density of air is 1.225 kilograms per meter cubed. The C that we are going to be dealing with is 0.47, and then the area of the ball is the area of a circle instead of a spear, because it's dealing with the circle traveling through air, a circular traveling through a one-dimensional plane, basically traveling through the air. So that's why we use the area of a circle. And then the air is going to go opposite, the force is going to go opposite of the gravitational force, so it's going to be negative. And then we use in the place of velocity that this would typically be, we are going to use the momentum over the mass, which will give us sufficient answers. And then for the initial time, I put 0, and the time step is going to be 0.01 seconds. That way we do a lot of calculations. And then I told it to do a rate of 100, and then the net force is going to be the gravitational force plus the negative air resistance force. And the momentum, the momentum is going to be the initial momentum plus the net force times the time step. And the position is going to be the position plus the momentum over the mass, which is sufficient for velocity, times the ball time step again. Now I wanted the time step to be defined as the initial time, the time to be defined as the initial time plus the time step. And I printed out the final ball position, which is 0.96 meters in the X direction, the X plane, and the total time in flight is 0.58 seconds. So next, this program is the same thing, just without any air resistance forces, and the ball will go further and it will take more time. It will be in the air for a longer flight. So